That's okay. All
Yeah,
right.
just make you the work.
So IUPAC names for R and S. Have you guys done this for stereochemistry?
Yeah,
Do you guys understand R and S or are you confused?
I understand it.
Okay. So just real quick, what does R stand for?
I don't know what they stand for, but I know how to name them.
I know which way it goes.
Right. R is right. So your molecule is right, which
Oh.
means if you do your stereochemistry, it is clockwise. S stands for what?
Left.
Doesn't stand for left. It
Left.
means left, but it doesn't stand for left. It's the left. Are you saying that this is what S stands for?
Yep.
Yes.
No.
Dr. Dewis calls it the devil something. I don't remember.
Yes, because this is this is Latin. Sinister.
Oh, okay.
Quick question. Are any of you Catholic?
My mom is.
So if you talk to your parents, ask them if they've ever known anyone left-handed, and they're going to tell you no. Because the Catholic Church used to think that if you were left-handed, that you were evil. So they would break your left hand and force you to learn how to write with your right. When I went to Catholic school for elementary school, the nuns would hit my hand. They didn't break my hand, but they would hit it with a ruler. So I now know how to write with both hands. Really the only benefit I got from Catholic school. But
You really outsmarted them.
well, no,
True.
I learned so I didn't get hit. I don't know if that's outsmarting, that's just surviving.
I went to Catholic school in Spain when I studied abroad, and it was like really scary sometimes because we would pray, like we had to go to church every Friday, and we had to pray every like day in class.
Well, I mean,
Before
don't forget that's where
class.
the Spanish Inquisition happened, right? So
Yeah.
when it comes to following the rules about church, they know what they're doing. But S is just sinister for left. So that means that you're going to do counterclockwise. And that's all S and R stand for. So when you guys get to sugars and things like that, you'll notice that they have their nomenclature is L and D. L for left and D for dextrose. There was this argument a long time ago about which one got which letters. And as a compromise, they said one will have one normal letter, one will have a Latin letter. So fun fact. But this is it. So the important thing is when you're doing your stereochemistry, there are a lot of ways that you can do this. It just becomes what's the easiest way for you. All right. So how good are you guys at spatially reassembling stuff? I'm going to say you guys probably aren't that good. If I draw a molecule, can you envision it in your head rotating 360 degrees any way I tell you to?
Mm.
Okay, we're going to do this the easy way then. So when you're doing your right and left nomenclature, right, you have to always make sure you arrange your molecule correctly. So in order to have the proper name, the proper stereocenter, which of your constituents, 1, 2, 3, or 4, has to be on the dash?
4.
4, right? So let us number right now. What is my smallest substituent?
So when you, okay.
This is 3, this is 2, and this is 1, right? In this case, it's just the number of carbons. As you learn more and more functional groups, you'll learn which one get priority. Essentially, the highest priority goes to the atom with the highest molecular mass. So carbon takes precedence over hydrogen, nitrogen takes precedence over carbon, oxygen takes precedence over nitrogen, fluorine takes precedence. Whatever the atomic number is, the highest atomic number is what determines that. Okay, so is my smallest substituent right now on the dash?
No.
No. So what I would do is that I would simply rotate this in my head to say, well, let's just rotate this bad boy and get this the right way. And when I rotate it, I would say, oh, this is clearly S. But for you guys, we're going to do this the simplest way. Draw a nice little circle and draw your other. So we're going to say, we're going to leave our smallest one alone and the one that's on the dash alone for right now. Draw the other two things. Like this. All right, we're going to draw those two like that, okay? Now, all we're going to do is imagine my carbon here is I break off the 4 and I break off the 3 and I just switch them. So now here on the dash is just the methyl, and here in plain is the ethyl now. Does that make sense? I just switched them. All right, so my numbers are still the same. 1, 2, 3, and 4. Does that make sense that I just switched 3 and 4 to put the smallest one on the back thing? Okay, so now to do this, go from 1 to 2 to 3. And which way did I go?
You went to the right.
So is this, I went clockwise. So would this, does this look like R or S? R. But because I flipped those two things, right?
Mm-hmm.
I have to flip
It's an
this.
S.
So it is actually S. Does that make sense?
Yeah.
How are you guys with doing that on a problem? Does that seem like a really simple thing to do? I'm pretty sure one of your professors has told you that.
Dr. Dewis just told us, like, if you don't see, like, if you visibly don't see the dashes, like, because we originally had gone right, but because 4 like isn't on like a dash and you can't see it, and instead it's like on a straight line, or it might be a wedge, it would just be an S, like just the opposite.
Maybe. I'm not trying to be difficult, but this is it could be, it may not be. It just depends. I would say go with what she tells you, right? That's my underlying theme here. Always go with what your professor tells you. But if her way makes sense, do it her way. If my way makes sense, whatever, right? So, but always go with her first, right? Follow her thing. This is just my way to have you do it real quick. Okay, so again, here, I'm going to do the exact same thing. So this is 1, this is 2, this is, so wait, hold on. I'm numbering backwards. I'm sorry.
Yeah.
This is 4, this is 3, this is 2, this is 1, right? And again, I'm going to draw the ones that are not what I want to move. So now this is going to be 1, 2, 3, and then this is going to be just the methyl. That happens again. So again, this is 1, this is 3, this is 2, and this is 4. So 1, 2, 3. And it looks like R, but since I flipped both of those things, it's actually S. Does that make sense?
Mm-hmm.
You can say no.
Yeah.
Okay. Whatever way is easiest for you, that is whatever you should do, because these problems, you should get through them in about 10 seconds. It does take practice, but you want to get through these simple ones as quickly as possible. Okay, so draw the structure 6,2-hexene. Clearly show the stereochemistry. Do not use dashes or wedges. So what should be the first thing you do every single time when you have a double bond molecule? Draw the double bond first. This makes my life a little bit easier if I draw the double bond. Okay, so what carbon does your double bond start at? It tells you in the name. It starts at 2, right? And then the next carbon has to be 3. Okay, so how many carbons need to be in this chain?
6.
Okay, so I'm going to draw carbon 1, and it doesn't matter which direction you go, right? Now, this is cis, okay? So if this is my CH3, that means that I have a hydrogen here, all right? So now on this side, right, I have 3 more carbons to draw and a hydrogen. Should my hydrogen be going up or should my hydrogen be going down?
Up. And let your hydrogen go up.
Yep, because you want the 2 biggest things to come at you at the same side and the 2 smallest things from going to the same side. So 4, 5, 6. This would be cis 2-hexene. All right. There are a number of ways to do this. Any one of them is just fine. I always find it's easier if you draw the double bond first, simply because if I drew my molecule like this, right, then I'm going to have to rotate it because I drew it trans. So that's why if I start with my double bonds, that makes life a little bit easier. Maggie, you look a little confused.
I don't know. How did you know that there's a pi bond?
Hexene.
Oh. Okay.
Don't forget ane, single bonds, ene, double bond, ine, triple bond.
Okay. That makes sense.
Okay. Assign R or S to the following stereo center. So you guys go ahead and try this and see what you get. Okay. I want to point out that this right here, I hate these. I forget what projections those are called, but I hate them with a passion.
Fisher projections?
Yes, Fisher's a jerk.
Yeah.
And he's dead. So who won that argument?
Oh.
Just kidding. I'm sure Fisher's a very lovely person. Is bromine
There's
stronger than fluorine?
No.
It's not strength. What did I tell you gets priority?
Weight.
The atomic number or mass?
Atomic
number or mass, whatever the largest one is.
Or mass, yeah. Doesn't fluorine have a higher mass?
Okay, just try to figure it out and we'll go through it. So just try to come up with an answer.
I lost my periodic table.
Okay.
It ran away.
I cut the one out of my 151 lab book and then I never saw it again. Okay, so bromine is. What if there's never mind.
I'll tell you the same thing I told you earlier. Just try to solve them and then we'll go through them. Make your mistakes because you learn best when you make a mistake and then it's fixed. Actually, you would learn best if I hit you after you made a mistake, but we're far away and not that angry.
Yes.
Well, maybe Morgan. Did I throw a marker in our class? I don't think I did it for our class. I used to do that in my lab classes.
I used to have a psychology professor when she was talking about I don't even remember, but she would throw markers at somebody to show their reflexes, but she just do it randomly.
Yeah, I would be afraid to do it for that point because I know plenty of people have terrible reflexes. I used to do it if kids were sleeping. I would throw a piece of chalk at their head.
Deserved.
Well, it's what did I tell you guys about using your cell phones or other stuff if you're in class? What did I ask of you if you were going to sleep or do other stuff? Move to the back. I was like, if you're in the back row, don't care what you're doing. You're here, whatever. But don't do it in the front row so that you distract the people behind you.
My Bio 182 professor was really scary about cell phones. Even if I didn't have the cell phone, I'd be scared whenever he'd yell at someone in class.
No, I don't. I could get mad about cell phones, but really, what's the point? I have a cell phone. I'm using it right now.
Did you have Dr. Stoltz, Morgan?
Yeah.
I remember that.
He did it twice in one class period, and I was terrified. And they're on the other side of the room of me.
Oh, Bushman.
Paying attention. Like that scared me so bad because I didn't think that he was would do that, but then he
What's her
did.
name? Bushman?
Oh, I had her for a year.
Yeah, I have to score up with her at some point. I have to challenge her to a duel. I owe
Didn't
it
she,
to a lot of
like,
kids.
Asked someone to leave because they were on their phone. Like she literally like told them to leave.
Yeah, she would like kick them out. It
She
was
just seemed
funny.
unnecessarily mean, especially after the pandemic. Like her exams got just stupid hard for no reason.
Yeah, I like failed one of them. I remember that.
You should have come to our study group.
I think I did.
I was gonna say, did you guys know that I did study group last year for calculus, physics, biology, and chemistry?
I didn't know that.
Oh, well, I held them at the same time, so they were like every week. Like Monday was, I think, our chemistry night. Tuesday was physics. Wednesday was calc, and Thursday was biology.
I saw you once when I was at an SI session, and you brought candy.
Oh, I think I was there. It was
But I
before
was just-
the exam or something like that.
I was too scared to like talk to you.
Why?
Yeah.
You've seen me in real life. I'm not a scary person.
I know, but I don't know.
If to make me more human, I'm gonna pause this recording real quick.
Chet West, not Tempe.
I don't know about West, but I know the main campus was hiring. Okay, so for our molecules, our first one, and we'll go through it, but our first one should be R.
Oh.
Our
Yes.
second one should be S. And our third one should be R.
Okay. Can you explain the first one?
Yep. So this is the important thing. You were asking me about bromine, but that's bad because
Oh.
you fell for a classic trap. You look at the carbon you're supposed to say, I am thinking about, and I'm going to draw the wedge, right? I always draw my hydrogens just in case. What is my highest priority? Morgan.
Is it? I said bromine, but
Fluorine.
I guess that's not right.
Is the bromine directly attached to the carbon we're looking at?
No.
No, you look at the first atom.
Oh, I didn't know. Okay.
So fluorine, hydrogen, carbon.
Okay. And another carbon.
So what is my highest priority?
Your fluorine.
All right. Do I know what my second or third priorities are?
I think it's the carbon attached.
Well,
to
even
the
before that, this is something, can you
Okay.
tell right now, just looking at the carbons? You can't, right? And the hydrogen is going to be my fourth. Okay, so now what I'm going to do is I come back to so I have a bromine, and a carbon coming off of here, right? And then over here, I have carbon, and then a hydrogen like that. So which carbon gets priority? The carbon to the left of the bromines or the carbon to the right with the carbons?
The bromine.
Yep, so
Yeah.
this becomes 2, this becomes 3. So 1, 2, 3 like that. But since our hydrogen, our smallest priority is on the wedge, we automatically flip it. And it becomes
S.
Sorry, it's S right now, but when you flip it becomes R. Sorry.
No, it's okay. I should have known that was to the left.
Gwen, did you get that? Okay, second one, Fisher projections. Fisher projections are jerks. Did you guys get this one?
I didn't.
I didn't even really try because I.
Okay, so here's what you should do. Number your substituents again. So what's my highest substituent? OH, CHO, H, or C going down?
I thought it was the CH2Cl going down.
But don't forget though, what do you look at? Do you look at what's attached down the line? You
silly.
identify that and then you say what is immediately attached to it. Oxygen.
Is that what the arrows are for?
Carbon.
I'm wondering why they were there.
Hydrogen, carbon. Okay, so which gets first priority now?
Okay, so this isn't it the CH?
No. What is the first
Oh,
atom?
oh, sorry, oxygen.
Oxygen. Do not fall for that trap. This is going to get you every time. So this becomes 1, hydrogen is 4, right? This carbon here is attached to a hydrogen and to an oxygen, but that's via double bond. So it's 1 hydrogen and then 2 times oxygen. So if you have a double bond, it's 2 times that amount. If you have a triple bond, it's 3 times that amount. This carbon here is attached to a hydrogen, and a carbon. So which one takes priority? The one at top or the one at bottom?
The one at top.
The one at top, right? So I'm going to just erase these arrows here. So now I have successfully labeled everything. So now this is going to be 2. This is going to be 3. Your 4 is not important right now. So you just go 1, 2, 3. So which way does this look?
It looks to the
R.
right.
R.
It looks R, but here's the trick to Fisher projections. Your smallest priority, left, right, or up or down?
Left to right.
It's pointing to the right. If your smallest priority is pointing to the left or right, you flip it. If your smallest priority is pointing up or down, you leave it the same. Gwen, you look confused.
No, this is probably like the hardest thing that we've learned so far.
But does that make sense though to follow those
No, yeah, that makes
easier instructions? Okay. And finally, for our last one, right? Which one gets priority? This goes to a carbon, a hydrogen, and a carbon, right? So what gets first priority? Can you distinguish right now?
The carbon.
The carbon with the double bond.
Nope. This is why you're making your mistake. Don't think ahead. Just look at the first atoms they're attached to. Carbon, carbon, carbon. Is there any difference between carbons, or are they all the same? All right. But hydrogen is my smallest priority. So I can say that. Now I look at what that next thing is connected to, right? This carbon's double bonded to an oxygen, so that's 2. And then to another oxygen. That's 3 oxygens, right? This one here is connected to a carbon and 2 hydrogens. This one's connected to a carbon via double bond, so that's 2 to a carbon, and then 1 to a hydrogen. All right, so which one of these gets priority? Down, to the right, or to the left?
Down.
Down's going to get priority. What's the next one? To the right or to the left?
To the right.
To the right, because that's 2 carbons and this is 3. So 1, 2, 3, right? So this looks like it's S, but my smallest priority, the hydrogen's on a wedge, so I flip it. So this is R. So there's nothing wrong with trying to jump ahead with figuring out what the stereochemistry is, but make sure you are 100% comfortable before you do that, because after teaching organic for a long period of time, that is probably the biggest mistake I saw students make, is that they would look at the next atom before they considered the original atom. So I would say that's probably the easiest way that kids get confused. Make sense?
Yeah.
Gwen looks sad.
Just hate this so much. But it is what it is.
Gwen, it doesn't all make sense in your head.
Oh,
Unfortunately not.
Complete Fisher projection for all 4 stereoisomers of 3-bromo-2-fluoropentane. So this is going to be fairly simple. All you need to do is just make sure you know which way you're doing it. So how many carbons are in your longest chain? 5, because it's pentane, right? So carbon 2, it does, I would say go from top to bottom. So this is going to be carbon 2. What's coming off of carbon 2?
a hydrogen and a fluorine.
Yep. So I'm going to draw a fluorine and a hydrogen. It doesn't matter what. What's coming off of carbon 3?
A hydrogen and a bromine.
Yep. And it doesn't matter which way you do this, right? So now this is just going to be CH3 up here, right? Because that's the original endpoint. And then this would be CH2, CH3. And again, this is just the idea that, okay, so this is just what this should look like. So now that you have this original structure drawn, I want you to think about how you can draw the other ones. Our session's about to end, so I'm going to end this and then I'll reopen it and we'll go through it and talk about how to do this. So the first thing you always want to do is just draw one version and then come back to it, but we can get through this really quickly. I'll be right back in 1 second.
Okay.